Now we are at the second day of surface area and volume. See, surface area and volume chapter we have started, but not yet started any of the sum. Only last day we have discussed about all the formulae which you have already learned in class 9. Now today we want to start this all, but actually what is the main theme of our class 10 surface area and volume already I have told. We just recall it once. The main theme is combination of different solids. Okay, so let's start the sum. First of all, exercise number 13.1. Question number 1. See the question. Two cubes, each of volume 64 centimeter cube. So both the cube having the volume 64 centimeter cube. Okay, are joined end to end. So find the surface area of the resulting cuboid. Now two cubes, whenever you are just joining, suppose this is one of the cubes, this is one of the cube, another cube you are joining with this side by side or end to end. Then one cuboid will form like this. Volume of this one is 64 centimeter cube and volume of this one is also 64 centimeter cube because each of them has 64 centimeter cube volume. Now as both of them are cubes, so side length are same. So this is a, this is a, this is a. So now the resulting cuboid, this is the resulting cuboid. Resulting cuboid. Whenever both the cube has joined end to end, then we got the resulting cuboid. This is the resulting cuboid. This resulting cuboid, you see properly, the length is now not A only, the length is 2A. What is the breadth? A. What is the height? A. So there is no change in the breadth and height, only the change in length. So what do we write here? When both the cubes are joined end to end, then length of resulting cuboid equal to 2A. Breadth A will be centimeter because it is given in centimeter. Height, that is also A centimeter. First of all, you write like this, that side of each cube equal to A centimeter. A centimeter. So now we know the formula to find out the volume of the cuboid. What I have to find out here, the question is to find out surface area of the resulting cuboid. To find out the surface area of the resulting cuboid, I need to find out the value of A first. Correct? Now as volume of each cube has given 64 centimeter cube, so we can write A cube equal to 64. So A equal to cube root of 64 means 4. So side of each cube equal to 4 centimeter. Or you can write here A equal to 4. Keep it like this and then you write, therefore length of cuboid 2A, that's mean 2 into 4 centimeter, that is 8 centimeter. Breadth of cuboid 4 centimeter. Height of cuboid 4 centimeter. So length and height of everything we got. Now we can find out the total surface area. Therefore, total surface area of resulting cuboid. What is the formula? 2 into LB plus BH plus HL. What is length here? 2A. What is breadth? A. Height also A. So putting all the value. So 2A square plus A square plus 2 square. So it's coming 5 square. So 10 square. So 10 into a square means what is the value of a? 4. So 160 centimeter square. So look at one thing. If you will not find the length and height of the cuboid, then also you can find out the total surface area of the resulting cuboid by this way. Or if you want to put the length and height from the beginning only with 8, 4 and 4, that also you can do, no problem, according to your choice. A sum, the calculation of the sum, how you will complete, that is totally depends on you. If you do like this way, you will not find out the length and height separately. And if you don't want to do like this way, that with A will not do the work, what is the length and height, at first one you will put proper values, then you have to find out the length and height, then you have to complete it. Clear? So again we are just saying how the sum has done. Two cubes was there, both of them having the volume of 64 centimeter cube and having the same size length. They have joined end to end. So a cube has formed, cuboid has formed. So length of the cuboid will be double of the size of the cube, but the breadth and height will be same as before. Now, as we got the length, breadth and height, so I can find out the total surface area of the resulting cuboid. But I need to get the value of A. So I will get it as the volume of this cube is 64. So A cube equal to 64. By solving it, I can get the value of A. By getting the value of A, I can find out everything. Clear? Moving to the next one. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. Hollow hemisphere mounted by a hollow cylinder. The cylinder is mounted on it. Okay? So what has given in question? A vessel is in the form of a hollow hemisphere. The hemisphere is hollow, mounted by a hollow cylinder. The diameter of the hemisphere is 14. The diameter of the hemisphere is 14. So what is the radius thing? Diameter is 14. So what is the radius? Radius will be 14 by 2 centimeter. That is 7 centimeter. Okay. And total height of the vessel is 13 centimeter. Total height given 13 centimeter. Find the inner surface area of the vessel. So I have to find out the inner surface area. Now look at one thing. This complete height is 13. And radius of the hemisphere 7 means this is also 7. Correct? This height is also 7. So from 13, if I subtract 7, I'll get the height of the cylinder. Correct? And the radius of the cylinder is also same as the radius of the hemisphere. Now we have to find out the surface area, inner surface area. Look here, inner surface area means if you look inside, what you can see, what the surface you can see, that all will come in consideration with the inner surface area. What you can see, if you look in, what you can see? This curved surface area of the cylinder you can see. Along with the curved surface area of the hemisphere you can see. So this curved surface area of the hemisphere and this curved surface area of the cylinder, both of these if you add together, then you will get the inner surface area of this solid. Now what is the question? Inner surface area of the solid? Inner surface area of the vessel. So you can write directly inner surface area of the vessel. What will be? Curved surface area of cylinder plus curved surface area of hemisphere. Curved surface area of the cylinder. Formula is 2 pi r h. First of all, you have to write the formula. Curved surface area of the hemisphere. Formula is 2 pi r square. One thing you have to remember. Both the radius are same. Yes. So both the radius are same. So both the cases I can use the same r. But if suppose the radius of the hemisphere and the radius of the cylinder are different, in that time, whenever you write the formula, one of the radius is marked as smaller, one of the radius is marked as capital. Because you have to remember that whatever you are writing, it must match with the values whichever you have written in the figure. So this is your h and this is your r. So now you can put the value. For that we can take common 2 pi r. The value of pi, if it is not given, we will put there 22 by 7. Yes, it's not given. So put here 22 by 7. Calculation part you will do yourself. I will put the values on it. 7, h means 6 and r means 7. This much centimeter square. I think that calculation you can do yourself to complete the sum. Okay? So now we move to the next sum. I think you can understand this one. Okay. So moving to next question number 3. A toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere. Think properly. A cone is mounted on a hemisphere. Cone is mounted on a hemisphere. Okay. Next, radius of the cone is 3.5. So radius of the hemisphere is also coming to 3.5 centimeter. The total height of the toy is 15.5. Total height of the toy is 15.5. It's similar as the previous one, very related. Find the total surface area of the toy. Okay. To find out the total surface area of the toy, at first I need to get the height of the cone. This one 3.5 and this is also 3.5 because radius of the same hemisphere will be same always. So what will be the height of this conical part? This one we are just noting as h. So h equal to 15.5 minus 3.5. This much centimeter. So it's coming 12 centimeter. So I got the height as 12 centimeter. I got the radius as 3.5 centimeter. This is the radius denoting as r. So I can find out the slant height L. So what will be the length L? So L equal to root over of a square plus r square. A square means 12 square. R square means 3.5 whole square. I think you can calculate it yourself. Calculation is totally over. It will come in decimal after doing the square and after addition. You know the division method square root, so apply that to find out. So you will get the value of L. I will say only the procedure. Now you have to find out the total surface area of the toy. Yes, it is like this, no? Yes. So you have to find out the total surface area of the toy. Now, if I want to find out the total surface area of the toy, what you can see from outside? Look, you can find out the curved surface area of the cone. You can find out the curved surface area of the hemisphere. So you have to take the curved surface area of cone and you have to take the curved surface area of hemisphere. Okay. Now, what is the curved surface area of cone? Formula is pi r. What is the curved surface area of the hemisphere? 2 pi r square. Now look here, both the radius are same or not? Yes. So that's why I can use both of them as smaller. Pi r can be taken as common, it will be L plus 2r. Pi value not given, so it will be 22 by 7. Radius we have already got 3.5. L you can get from here, denoting as hashtag. 2 into radius is 2 into 3.5. This will be centimeter square. I think you can calculate it to find out the final answer. Okay? So this calculation part is completely of your work. So you can do it, I think, properly. So it's very easy sum. You have to remember like that whenever the question is like that to find out the total surface area. It means relative. Whenever you see from outside that figure, what you can see from outside, everything will come in total surface area. Clear? You can see from outside the curved surface area of the cone and you can see from outside the curved surface area of the hemisphere. So if both these curved surface area will add together, definitely you will get the total surface area of the toy. Okay? So now we are moving to the next question. See the question. A cubical block of side 7 centimeter is surmounted by a hemisphere. Cubical block of side 7 centimeter is surmounted by a hemisphere. Three figure cannot be drawn nicely. What is the greatest diameter the hemisphere can have? See, what is the greatest diameter of the hemisphere? The hemisphere having the circular face, and the greatest hemisphere will be that one for which the circle will touch all the side of the square, because whenever it is a cube, so all sides are same. So the upper face of the cube is like a square. It's like a square. Just I have drawn the upper face of the cube. Now, if it is the largest hemisphere, then the circular face of the hemisphere must touch all the sides. So in that case, the largest diameter of the hemisphere will be the side of the cube, 7 centimeter. Because the largest diameter will be equal to the side length of the square. And the square is actually the part of the cube, because it is actually the top face of the cube. So side length will be equal to the side length of the cube only. As the cube having the side length 7 centimeter, so all the sides have 7 centimeter, and the upper face is like a square. Whenever the largest hemisphere you have mounted on it, so the circular part of the hemisphere must touch all the sides of the square. So what will be the largest diameter of the hemisphere? The largest diameter of the hemisphere will be equal to the side of the square. So that we can write. What is the next question? Find the surface area of the solid. Okay, so two questions are there. First question, largest diameter of the hemisphere, and the next one is the total surface area of the solid. Total surface area, sorry, that's the total surface area. So write it first. The circular base, the largest hemisphere have the circular base touching all the sides of the square top of the cube, because the cube has the top a square. Therefore, the largest diameter equal to side of the cube equal to 7 centimeter. That was the first part. Next one, the surface area. Now just think what I have told at first. If you want to find out the surface area, that's mean you have to find out from outer side. Whenever you are just looking the figure, what you can see outside, everything will come in surface area. So what will come? Just to see all the 5 faces of the cube, not 6. Here properly. All the 5 faces of the cube, this hemispherical curved surface, and these corner positions. Everything you can see from outside, and everything will come in consideration of total surface area. So to find out the total surface area, you have to find out the surface area of the all 5 faces of the cube, curved surface area of the hemisphere, and this corner positions area. So how to find out? Surface area of the solid. What is the name? Yes, of the solid. Solid equal to surface area of 5 faces of cube, or you can write surface area of 6 faces of cube. Suppose 6 faces of cube you have taken, but suppose you can write here like this, total surface area of cube. So what you have taken is this surface area to total you are not getting, okay, because whenever you will mount a hemisphere on it, so this circular part is completely covered, so you cannot see it from outside. So you cannot find out the surface area of that. That's why I have put on the upper surface I will find out the surface area of the corner positions only. So how will find out that one? Whenever I have taken the total surface area of the cube, that means all the face area I have taken. But these 5 faces are completely free. But the top face is occupied by a hemisphere, not completely, keeping all the corners as usual. So whenever you have taken the total surface area of the cube, so this face area also you have taken. So now if I subtract the area of this circle, this circle area if I subtract, then which area has covered by the hemisphere on the top of the cube, that part I have deducted, I have subtracted. So only the corner positions are left along with these 5 faces, area of 5 faces of the cube and this corner faces area, because you have subtracted the area of the circle. So this circular face area, whenever you are subtracting from this, only the corner positions and the 5 faces of the cube are just there. One more thing you have to add, we have to add curved surface area of the hemisphere, plus CSA of the hemisphere. Now, total surface area of the cube. What is the formula? 6a square. Here a is 7 cm. Area of the circle. What is the formula? Pi r square. R we have to find out. And curved surface area of the hemisphere. What is the formula? 2 pi r square. So we are getting actually 6a square. If I calculate it, plus pi r square. Now radius we are finding out. Radius equal to 7 by 2 cm because diameter was 7. Keep it like this. A means 7 cm. Pi means 22 by 7. And r square means 7 by 2 whole square. So this much centimeter square. I think the leftover calculation you can do yourself. So this part you will do yourself to complete it. So how to do this one? I think you understand. Why I have done this one? This thing you try to understand first. Because this 5 face area we have to take for this cube. Whenever you will take the top face, then coming 6 face area. But from the top face, I have to subtract the circular part, because the circular part is occupied by the hemisphere, and whenever the hemisphere will mount over the top, then the circular part cannot be seen from outside. You will see the bulging face of the hemisphere only. So this corner faces only you can see from outside. So to get it, whenever you have done the total surface area of the cube, from there I have subtracted the area of the circle to get only the corner position along with the 5 square faces. And whenever I have added with this the curved surface area of the hemisphere, then the total surface area has completed. Because I have told total surface area means which you can see from outside, which has already gone inside, you cannot take that one. Which one you cannot see, you cannot take that one. Clear? So I think you understand this one. No question is here. So there will be a small homework for you, because question number 4 and question number 5 is very related, because there one hemispherical depression has made. So whenever hemispherical depression has made, so along with the 5 face area, along with the 6 face area, after subtracting the area of the circle, again you have to add the curved surface of the hemisphere. Why it is and how to do, you just think yourself. Question number 5 will be your homework. Okay? So you try this one. I think you can do this one. Only you just keep in mind what you can see from outside, everything will come in surface area, total surface area. Okay? So our class we are completing here today. Tomorrow we will start from question number 6.